Hello everybody, my name is Ismail Mohammed. Firstly, I would like to thank us for ICT for Development of Africa and Baghdad University Institute of Technology to give this chance, and the ICT for the coordinator in Baghdad University, Dr. Subalo Alamneh. Unfortunately, he's co-author on these papers. Unfortunately, we didn't see each other because of the current situation in Ethiopia, but let us proceed. My paper is on the identification of architectural significant non-functional requirement with two authors, me, Ismail Mohammed, and Dr. Subhano Alamna from Baghdad University. So let us start. Here are the table of contents that I will touch on this presentation. It is on the introduction, problem statement, something blah blah until future works. So when you say on the introduction, software systems, you know that a driver for every technology to develop a software systems, firstly we need to have a requirement and architecture. After we gather a requirements, we need have to develop or design the architecture. So software architecture can be derived or which is collected from either is a functional requirement, a non-functional requirement, quality attributes, technical constraints, and business constraints. So we can gather necessary requirement to design software architecture from those pointers. And to design a software architecture, we need to collect architecturally significant requirements. So architecturally significant, which is abbreviated as ASR. So ASR are requirements that affects and used to design a software architecture. To design a software architecture, we need to identify architecturally significant requirements. So more importantly, non-functional requirement highly affects a software architectures. But all the requirements, even if a non-functional requirement or a functional requirement, all the requirements not important for design the architecture. Important to design the architecture. For example, when you see non-functional requirements like usability is one of the NFR or non-functional requirement, as the study shows. Rather and Grant, it shows GUIR or graphical interface are one of the non-functional requirement. Actually, one of the architecturally non-significant non-functional requirement. But the user error protection like the undo, redo, and cancel are architecturally significant requirements. So incorrectly identified ASR or wrongly identified ASR, architecturally significant requirement, results wrongly designed architectures. So wrongly designed architecture leads to until the complete failure of a software system. Non-functional requirements more importantly affect the architecture rather than the functional requirement, the business constraint, the technical constraint. More importantly, non-functional requirement affects the architecture. So to identify correct ASR, we propose the identification of architecturally non-functional requirement from the SRS document of real-time system. So we proposed a machine learning model to identify non-functional requirement. Architecturally significant non-functional requirement. So real-time system is a time-critical system which is subjected to real-time response to events. So real-time system have relevant non-functional requirements. Have 11 relevant non-functional requirements. From those relevant requirements like timing or the performance, reliability, safety, availability, security, usability, and the maintenance are the critical or high-level non-functional requirements. So high-level non-functional requirement means that missing those high-level non-functional requirements is highly risky, or it leads architectures to wrong design. The wrong design leads to the complete failure of the systems. So on this research we build a model, we proposed or we build a model for the identification of architectural significant non-functional requirement of a real-time system using machine learning approaches. When you see the problem statement in software development, design a software architecture, the fundamental or core part of software development process. So identifying important requirements used for architectural design is the first phase in the architectural design. When you see the characteristics of architectural significant requirement, ASR are hidden, initial, neglected, hard to define. So those characteristics of ASR, it makes the ASR complex to identify those requirements using human involvement. So the characteristics of ASR makes identifying ASR make complex in human involvement. So we need have to automate this process. So to identifying ASR from SRS document, human involvement is an error-prone and time-consuming task, which is resulting in incorrect identifying of ASRs. So automatically capturing of ASR can fill the gap of accuracy of ASR and the time it needs to identify the significant requirement from all of the requirements of their requirements. So in this study we proposed a machine learning based model to identify architectural significant non-functional requirement of real-time systems. So when you see the research question, basically when you do these researches, we plan to answer those 3 questions. The first one is how to classify quality attributes to architectural significant requirement and not significant requirement. The second question is how we can build a machine learning model to identify those significant requirements. The third question is machine learning techniques, especially from the SABM, the KNN and Naive-Bayes algorithm, which one will be performs better on this problem, and what are the parameters or what are the hyperparameters of those algorithms which is suitable to build the models. So when you see the objectives, the general objective is we aim of these studies to build a model that enables to identify a significant non-functional requirement automatically from SRS of a real-time software system to achieve the general objectives. We specifically do the specific objectives. From the specific objective, the first one will be to prepare a data set from different literatures, online public data sets, from books and project of SRS document, which is worked for real-time systems. And the other specific objective is to create a decision criteria. Those decision criteria help us to classify the non-functional requirement. Is it significant, or is it architecturally significant, or is it not architecturally non-significant? And the other is to evaluate the hyperparameter of those 3 machine learning algorithms, which hyperparameters performs better than the others, or the hyperparameter values of those algorithms. And the other is to build and evaluate the machine learning model for automatic identification of architecturally significant non-functional requirements. And the scope of these studies, in this study we have developed a machine learning model for architectural significant non-functional requirement identification, but in the limitation as a data firstly on the introduction we say that the determinant, or we can derive significant requirement from non-functional requirement, functional requirement, business constraint and others. We say that, but on this study we only focus on non-functional requirement. We didn't study about the business constraint, the technical constraint and the functional requirements. So we didn't have exact related works, but it have somehow related works. When you see the Metran and Maho 2017 paper is published in Springer Journal. The architectural significant requirement identification, classification, and change management for multi-tenant cloud-based system is not the limitation is not an automatic solely about empirical studies, and the others Abraham et al. Papers, it also a method to drive software architecture from quality requirements. It shows about what are the methods to drive software architecture from quality requirement, and the other what you ask is what we get. Understanding architecture significant functional requirements to only focus on functional requirements, but it didn't. It's not an automatic. It's only so about the empirical study, and the other. This one was identifying architecture significant functional requirement, which is work on machine learning algorithms, traditional machine learning algorithms. One of the limitations only for functional requirements. They didn't cover about non-functional requirement in the deep learning version of this paper. This one is a deep learning version of the above, the identification, classification, architectural significant functional requirement. This the limitation of this also is only focus on functional requirements. Functional requirements, those papers they didn't study about non-functional requirements, but we say that non-functional requirements more important and affect the architecture than the functional and the other determinants. So there are also so many researches on the classification and identification of requirements, but they didn't include architectural. Which one is the following is architectural significant, which is not architectural significant. They only study about the requirement, which one is functional requirements, which are non-functional requirements. So on the methodology part, we done this research on using experimental study. Firstly, when we design this study, we break down the study on 3 parts: pre-processing, the pre-processing, pre-design, design, and post-design. On pre-design, we done data collection and annotation. On the design, we done pre-processing, feature selection, and model building, and on the post-design phase, the model evaluation and result discussions. So on design, the first one is pre-processing. On pre-processing, we done so many tasks like hyphenated component splitting, lower casing, stemming, lemmatization, and the other process tasks. On the feature selection task, we select what are the feature which help us to help us the machine to make it significant or not significant. So we done both on TF-IDF and word embedding, like the pre-trained word to vec models. We done on feature selection and the model building. We done both on 3 machine learning SVM, NB, and KNA model evaluation. We evaluate the models using tenfold stratified version of K-fold cross validation model. On data preparation, we gathered a real-time system non-functional architecture significant non-functional requirement, different source from 11 relevant non-functional requirement. We used 634 data, 368 which is were from significant and 266 were not significant. So finally we collected the attributes and definition of from ISO 2011, the latest version. This one is the example we done on data collection. First we collect for 11 relevant non-functional requirements. When you see the usability, we collect from ISO what are the attributes. Those are the attributes for usability, and we collect from papers like this. From papers, which one of the attributes is categorized under significant ASR, which is not significant like this. When you see the learnability attribute is categorized under significant, the user interface look and feel something are under not ASR like this. We gather the data, the criteria, and we give for data annotators. The data annotator annotate our around 600 data using this criteria. Okay, using this criteria, finally we get, after build the model, we get this accuracy, the SVM algorithm performance 88% using TF-IDF and 73% using Word2Vec, the pre-trained Word2Vec version. Then NB 87% in TF-IDF, 87% also performs the KNN using TF-IDF. So the SVM with TF-IDF model increases by 1% from NB and KNN, like using the TF-IDF, and 8% and 30% from NB and KNN with Word2Vec. This is why SVM performs well when the number of features selected is larger than the sample data, which is true in our case. Our training data is less than the feature selected from our data. But the reverse is true in the KNN NB algorithm. That's why SVM perform from NB and KNN. And the other point is NB algorithm assumes the features are independent of each other and have equal contribution to the target class. This is wrong, not only in our case, also wrong in real life situations. That's why NB performs worse than the SVM. When you see the TF-IDF, the feature selection, our feature selection techniques is the TF-IDF, and the software engineering pre-trained Word2Vec models, the TF-IDF outperform from the pre-trained Word2Vec model in all experiments. This is why this pre-trained Word2Vec model is trained using Stack Overflow posts some vocabularies or words in our data which is not found in vocabulary of the Word2Vec model, so that missing data, the missing words under the Stack Overflow posts or the Word2Vec model, which is minimize the performance. That's why TF-IDF performs better than the pre-trained Word2Vec. So finally, when you conclude, we build a machine learning model using SVM, KNN, and NB algorithm with the TF-IDF and pre-trained Word2Vec models. And the model is evaluated using, we evaluate our model using tenfold cross-validation, the stratified version of tenfold cross-validation, and we find the optimal parameters, or we find the best performing hyperparameters using research cross-validation. And the SVM with the TF-IDF are the best performing model in the identification of architectural significant non-functional requirement. We think that we contribute in this paper. We have those points. We have prepared a dataset for the identification of architectural significant non-functional requirement. We have developed an architectural significant non-functional requirement identification model, and we calculated the optimal hyperparameters or the best performing hyperparameters for the SVM, NB, and KNN using our dataset. And we prepare the performance. We compared the performance, or compared the performance of the three algorithms, that the SVM, NB, and KNN in our problem. And future work, we recommend to study other researchers on a study for other determinants like the functional business technical constraint. We didn't cover about the functional business technical constraint, so other researchers can focus on those points. And also we recommend for studying using more data, studying this program using more data. We use around 600 data, that's very less. We know that. So when you study more data and using deep learning, we recommend that which results the best performance. And we recommend creating a Word2Vec model with a large amount of quality attributes data. We say that we used the pre-trained software engine pre-trained Word2Vec model, which is downloaded from internet, which is creating using Stack Overflow posts. So other researchers other researchers can build their own word-to-vec model using exactly local attribute that may give us a good result on this problem. So that's all. Thank you everybody. Bye.